So we continue. So in the previous video we said these are some of the fields where we find application of electronics. So that is a communication system, computing system, control system, as well as medical equipment and power electronics. So now a classical scenario is when you speak into your phone. So what happens is that your voice or the sound wave is going to be converted into an electrical signal by a microphone, and then that electrical signal is then going to be processed by an electronic circuit before it is transmitted to another phone. So I repeat, so when you speak in your phone, the voice of the voice you produce when you... So one catching thing which I would like you guys to remember is the concept of what a circuit is. So it may have been the first thing to be mentioned. So recall that a circuit is basically an interconnection of elements. So that's what we call a circuit, when we have an interconnection of elements and we are able to manipulate them in such a way that they can perform some work or do a specific task. Then we have a circuit. So now one thing you want to now talk about is how we classify electrical signals, because we have heard that when you speak through your phone, that sound wave is first converted into an electrical signal. So the schematic is like this: sound is converted to an electrical signal, then that electrical signal is now converted to an electronic signal. So let's look at now the classification of electrical signals. So we basically classify electrical signals into two. So number one is the analog signal. Then number two is digital. Digital. So these are the two types of signals which we have. So let's look at what an analog signal is. Analog signal. So when we look at what an analog signal is, this deals with continuously varying signals, i.e. voltage or current. So we say analog signals deals with continuously varying what? Signals. So this can be either a voltage or current. So this is common in systems where signals represent physical quantities such as sound or light. Common in systems where signals represent physical quantities such as sound or light. So this is where you can find an analog signal. So a good example is a microphone amplifier, e.g. microphone amplifier. Then number 2 is the analog signal, which we all know, which was in the television set as well as the radio set. Although most of these are being phased out, but these are some examples. Then last is the volume control knob. So as we are building up, I want you guys to take note of this point. So analog signals can take up any value within a given range. So it's the opposite when we talk about digital signals, and you'll see why. So we move on. Number 2, the other classification of electrical signals is what we call the digital electronics or signals. So this one, it deals with discrete signals. This deals with discrete signals. So these are usually represented by zeros and ones, and also they are used in systems that perform logic operations. A very good example is in a computer processor. So let's say you can find this in number 1, computer. Number 2, a digital clock, which has replaced the analog clock. And then lastly, you also find this type of signals in calculators. So now remember, I mentioned to say the key point about analog signals is that they can take up any range, any value within a given range. They take up any range of values. But when we talk about digital signals, one thing you're supposed to note is that digital signals are more prone to noise and are easier to automate than analog signals, and you'll see why as we proceed with the course. So now let's try to now summarize the main features and differences between analog and digital signals. So let's say so here we're going to have a feature, then here we'll have an analog system, then here we'll have a digital system. So number 1, let's look at the signal type. So in an analog, it is continuous, but in a digital, we've already seen that it is discrete, zeros and ones. Most of you know this as a computer language. Then number 2, let's look at the accuracy. So in an analog, this is affected by noise, but when we talk about digital signals, it has a very high accuracy. It is not prone to mistakes. Okay, so moving on, let's look at the speed. And by speed, I'm sure you will already have an idea, because we've said that most digital systems have replaced analog systems. So when we talk about the speed, for analog systems, it is only fast for simple operations. But when operations become complex, it is very slow. So this is when you have to use a digital signal. So this one is fast for complex operations, like that. So now moving on, some examples which helps you to differentiate the two is that you can find an analog signal in, for instance, an amplifier. And for a digital, I would like you to always think about a computer processor, because it's the one which contains the part which does most of the logic operations. Okay, moving on. But remember that this course is limited to okay, not only but mostly electronics, because it is introduction to electronics, but we want to separate it so that there's no confusion when we are referring to either electronic or electrical circuits. So that's the next section. So the next section says differences between electrical and electronic circuits. And there is by far no better method of putting these differences than just using a table. So it's going to be quite a long table. Okay, so here just say feature, then here we'll be talking about electrical circuits, then here we'll be talking about the electronic circuit. So number one, let's look at the nature of the current. Then we're comparing it to the electrical circuit and the electronic circuit. So in an electronic circuit, the type of current found is usually AC, or you can have DC, but it will usually it will have a high power. Then when you talk about electronics, you rarely find AC, so it is just mainly DC with small current. Okay, so that's it about the nature of the current which we find there between our electrical circuits and electronic circuits. And then recall that we said that circuit is mainly an interconnection of circuit components or elements, as you may want. So now we want to know the main components which are required to make an electrical circuit or an electronic circuit. So in an electrical circuit, you mainly use elements such as resistors, inductors, capacitors, motors, and switches. So these are the ones you mainly use. And then when we talk about electronic circuits, we use components such as diodes, transistors, then integrated circuits, as well as sensors, because in most cases an electronic circuit is mainly designed for the purpose of automation. So this is why you see components such as sensors and integrated circuits. Then now when we look at the type of signal type, so in an electrical circuit, the signal is mainly power oriented, and it has a high voltage and current. Then when we talk about in an electronic circuit, this one is mainly information oriented, and at the same time it has a low voltage and current. So that's about the type of signal which you find in the two. Then now another thing we want to look at is mainly the purpose for either the electrical circuit or the electronic circuit. So an electrical circuit, in most cases, 90% of the time, it's designed for power transmission. That is why we design electrical circuits. Alternatively, for heating and lighting as well. Then when we talk about electronic circuits, so this one is mainly for signal processing, then control and communication. This is why we design electronic circuits. Another field we are interested in is the energy conversion that happens in the two. So in an electrical circuit, the electrical energy is converted to mechanical or sometimes some heat losses. But then in an electronic circuit, the electrical energy is not converted to anything, but it is used to process signals. Then in the last segment, we want to just look at some examples of the two to further solidify our understanding of the main difference between the two. So an example of an electrical circuit is an electric fan or a water heater. And then an example of an electronic circuit is a radio, a computer, or smartphone. Okay, that is the main difference between an electrical and electronic circuit. So in summary now, if we want to describe or define what an electrical circuit is, we can simply say, let's say, want to define what an electrical circuit is. So these are circuits mainly used to deliver power, e.g. powering a bulb. That's the main purpose of an electrical circuit. Then for an electronic circuit, it has many applications. Electronic circuit So these are circuits designed to control, process, or communicate information. Those are some of the purposes why we design electronic circuits. So an example of an electronic circuit, instead of just powering it up, it would be where I want to now control the brightness of the bulb. And this application is very important for you guys that have smartphones. I'm sure you've had a scenario where you want to control the brightness. If it's either too bright, you want to make sure that you increase the brightness, and in a situation where it's dark, you want to just reduce the brightness because there isn't enough light to distract you. Okay, so now remember, the name of this course is Introduction to Electronics, but we just wanted to have an idea of how electronics differs when it comes to electrical systems. So now let's go back to our main discussion, which is electronics, but in this case let's look at some of the applications of electronics. So number one, we use electronics in the industry. Then number two, in communication. Then we'll just look at 3 examples. Then number 3, we use it in automation. So in the industry, mostly what we're saying is that electronics can be used to monitor, control, and automate industrial processes. So an example is, for instance, where you want to control the temperature in a manufacturing plant. So we can use sensors and microcontrollers. So that is how we can use it in the industry. Then number 2, we can also use it for safety monitoring systems. So one of the benefits of using electronics in industries is that it increases efficiency and also reduces labor. And lastly, it ensures precision, because it's difficult, or in fact nearly impossible, for the computer to make errors as with regards to human beings, because human beings usually make a lot of errors, as you may already know. Then when it comes to communication, electronics is mainly the backbone of modern communication systems. So an example is things we've already seen before. For instance, a radio, a TV, mobile communication, internet routers, and satellites as well. So those are some of the applications of how we use electronics in communications. So now when it comes to the main role of electronics in communication, it mainly is involved in converting sound, images, and data into electrical signals for transmission and conversion on the receiver end. This is quite a process on its own, but we just want to say this is how it's used. If you want to study more about this, you can Google or just learn more. So then lastly, we can use electronics in automation. So automation simply means using electronics to perform tasks with minimal human intervention. So this is something which you may have seen if you are into manufacturing, you follow some videos on YouTube or elsewhere. You notice that mainly they are getting rid of human labor and they are replacing it with computers. So this is because it is for a number of reasons. You want to make sure that you perform a certain task at a faster rate and with minimal errors. So an example of how you can automate a system using electronics is the situation which we see in automatic doors. So that one, it uses infrared sensors. And then even in smart irrigation systems, electronics is applied there. And lastly, in robotic arms in assembly lines. So you notice that most of these vehicle manufacturing plants, they've replaced human labor with robotic arms. So these are the ones which put the assembly parts together. They put the doors together or other parts simply using a computer which has been automated. So now let's look at the core principles of how electronics works. So let's say core principles. So mainly when it comes to electronics, we have what are known as sensors. Then we also have what are known as microcontrollers. Then we also have what are known as actuators. So for sensors, these basically, you may have an idea, they just detect changes. Then when you talk about microcontrollers, these process data. That's their job, just to process data. And then actuators, these are the ones who now perform the action automatically. Perform the action automatically. So that is the job of actuators. So this has been the first lesson in the introduction to electronics, diploma level. In summary, we can summarize everything as by saying electronic plays a vital role in simplifying human effort, increasing productivity, and improving communication and control in almost every field. So some of the main points which we have discussed is we can say, in case someone asks us, how would we describe electronics? So electronics is the control of current through semiconductor. This is the control of current through semiconductors. And then we said that for analog signals, these are continuous. Remember we said it can take up any given range of values. Then for digital, it is discrete. That is what we said. It can only take up zeros and ones, also known as computer language. So then when we looked at the main differences between electrical circuits and electronics, we said electrical circuits, they mainly focus on power delivery. Then electronic circuits is focused on signal controls, mainly about how you can control a circuit. So this has been the introduction to electronics first tutorial. Hoping to see you guys in the next tutorial. Be sure to hit that like button and subscribe to my YouTube channel.